Good afternoon, everyone. Thank you for joining us for today's webinar. I'm Ryan Siegel, joined by my colleague Sean Maurer, and we're with the Smart Energy Design Assistance Center here at the University of Illinois. Today's presentation is being recorded, and the recording, along with the slides, will be shared with everyone, along with posted to our website following today's session. Along with that notice, when the presentation is uploaded, you will receive a certificate of participation along with several links. One of those included will be a link to a survey. We do appreciate if those of you can go ahead and fill those out and provide us feedback on today's presentation. It's greatly appreciated and helps us out as we are developing future presentations. If you do have any questions during the presentation, please go ahead and use the question and answer functionality built into the Zoom platform. As I mentioned, I'm joined today by my colleague Sean Maurer. And today's presentation is going to be a little bit different because today's presentation, rather than focused on necessarily the specific content of the code, we're going to be focusing mostly on the process of how we develop our code answers, recognizing that as you are working in the field and in your practice, you're often going to encounter questions about things, and so helping to provide some insight as far as how we go about answering some of those questions, looking at several real-world examples as questions that people have submitted in the past, and recognizing that we are dealing with several complex scenarios for energy code compliance. Our primary function, again, we're housed at the University of Illinois, is to reduce the energy footprint, both in the state of Illinois and beyond. And these energy code trainings are one method that we use to accomplish that mission. So we are an applied research program, so we do appreciate and like to be able to get out into the field and help you all. Part of what we deal with is education, being a University of Illinois affiliate, along with research and some advocacy towards a greener future, recognizing that the energy code continues to progress and help buildings reduce their energy consumption over time. Today's training is made possible through support of the Illinois State Energy Office, housed at the Illinois Environmental Protection Agency, and so we do appreciate their support of our program and making today's session possible. As I mentioned earlier, following today's webinar, everyone will receive a certificate of completion to all participants. As if during your registration you provided us your ICC member information or your AIA member information, we will go ahead and get those credits filed on your behalf, but everyone will receive the certificate of completion for those organizations that do self-reporting of credits. Our Energy Code training program has several aspects to it, including our technical support helpline, energycode@illinois.edu. So if you do come across questions, go ahead and feel free to reach out to us, energycode@illinois.edu. We do have an 800 number for your use. If you do have just a quick question, I remember there was this provision. Can you tell me where that's located in the code? Go ahead and you can use our 800 number. But again, our preferred method of communication is that email address, energycode@illinois.edu. That allows everyone in our team to provide the input on the response, and we can provide you a written response back to your question, which can be very helpful for working with the project team and the code officials, that everyone's able to read from the same response rather than well, I heard from this person who told that person. So having that written response oftentimes seems to be quite helpful. We also have several online resources at our website, smartenergy.illinois.edu/energy-code. This includes upcoming as well as archives of workshop presentations, along with archive and upcoming webinars. So the recording is also posted there, along with several online on-demand training modules. These training modules are designed or targeted for more of a beginning audience, so people don't need to be experts in codes to find these to be useful. So I believe there's something on the order of 20 different learning modules now up there. So as far as our webinar series, today we're talking about questions and answers, how we answer your energy code questions. You can see we've covered a few different topics already yet this fiscal year, including starting from energy code basics and looking at existing residential. Also touched on the residential stretch code, and we've got several presentations coming up. Our next one on commercial stretch code will be coming up later in February. So if you would like to register for any of these, you can find that on our website, smartenergy.illinois.edu/events. We do also have one in-person workshop coming up, looking at March 19th. We are still working to determine the location for that. That's going to be a 3-hour workshop in person. So if you want to see us in a little bit more depth, it's an opportunity for that coming up in March. Big question that we anticipate people may have on their minds is, when is Illinois moving to the 2021 IECC from the 2018? This has finally been announced, so Illinois will be moving to the 2021 IECC with applicable Illinois amendments beginning for permit applications dated starting January 1st of 2024. So for those projects that may be wanting to still use the 2018 IECC for code compliance, they still have a few days left to get their permit applications in. Otherwise, that's going to need to demonstrate code compliance using the 2021 IECC with Illinois amendments. So we do have also links on our website. You may have seen earlier the reference to the Chicago Energy Transformation Code, along with, we do have links over to the 2021 IECC, along with the Illinois amendments that have now been posted to the Capital Development Board's website. So, Chicago Energy Transformation Code, again, is one of the only codes that we're aware of that's a more fully developed code or comprehensive code beyond the Illinois, that uses the 2021 IECC along with a handful of amendments, and then local jurisdictions may also have some further amendments to increase the stringency. As I mentioned, today's presentation is going to be a little bit different. We're going to be focusing on the process, not so much the specific provisions themselves. So we do encourage people, we recognize there is going to be a whole lot of words on these slides as we're going through this, because we are going to be using screen captures of the code text language. So with that, we're going to be using a fair number of screenshots that's going to have a lot of text on them. So we encourage people, don't try to read all the text that's on the screen. This is mostly about the process. So with that, I'm going to turn it over to my colleague to kick us off with our first question.
All right. Well, thank you, Ryan. Appreciate it. So our first question here was one that came in. We were originally asked if these highlighted sections here that contain a corridor space with some workspace areas and kind of an open plan layout integral to the corridor. And they were asking if that entire highlighted space would qualify as corridor and get those corridor lighting controls. This was back under the 2018 where corridors were exempt from lighting controls. So they were trying to get around not having to install open plan, open office lighting controls. And so the answer to the question is first, what are these areas designated as? They could be designated as open office. They could be a combination of open office and corridor space. Most likely they would not be corridor space alone, though. And so with that answer, now we go back into the code to figure out what the requirements are for the space. So first, we go to section C405.2.1.1, where it talks about occupant sensor control functions and what those requirements are. And the main thing we're looking for here is there anything more specific for these space types that we're looking at? Is open plan offices called out specifically, or are corridors called out specifically that have more stringent requirements? So the first thing we can see here is that open plan offices do have a more specific requirement. It's underlined here. And corridors also have a more specific requirement. So there's occupant sensor general requirement, but we also have more specific requirements for open office plans and corridors that we have to reference now. So the open plan offices is in section C405.2.1.3. So if we scroll down through the code, we find that section. These are the requirements for that open office plan control sequence. As you can see, lots of requirements, pretty detailed. For the corridors, that's section C405.2.1.4. Those are slightly less stringent requirements as we get to that section. So you can see here is just a requirement for this 50% reduction. So again, going back to the space designations, figuring out, are those open plan office alone? Are they open plan office with a corridor space adjacent to them where they're kind of interconnected? Either one of these or both of these would apply to those spaces. And then you have to work through the code to figure out what the requirements are to actually implement for those space types. I will turn it over to Ryan to cover our controlled receptacles question.
Thank you. And you bring up a good question as far as recognizing how spaces have been used. You may have encountered in your practice where you just have an extra wide corridor that has some lateral files on the wall or things like that. Looking at the space use and saying, okay, this is a corridor space, or you may have corridor with adjacent open offices. And so understanding, what is practical, feasible, and possible with those, and recognizing that sometimes the answers aren't always clear, but recognizing that you can have spaces that are adjacent to one another, and making sure that we're capturing that appropriately. So our next question covers receptacle controls. This is fairly new to the code. And so coming up with the 2021 IECC requiring controlled receptacles, wanting to know, for an existing building, we have a tenant space being renovated and they're going to leave most of the existing receptacles in place, and trying to understand how does an existing building need to comply with controlled receptacles with that. And so the answer that we have here is that the existing receptacles, we don't have to add controls to the existing receptacles. However, existing controlled receptacles can't be removed. For those of you who are fairly familiar with Chapter 5, a big item is you cannot make anything less compliant with the code than it was before your renovation. So if you have existing controlled receptacles, you can't remove them because that would be making the building less compliant. So we always start, for existing buildings, we're going to be starting in Chapter 5. with any question we get on an existing building, we always start with Chapter 5, whether it's commercial or residential. So recognizing we're starting in alterations with 503. So 503, we read through, are there any particular provisions? Because we started in Chapter 5, and then from there, what provisions send us back to Chapter 4 as far as what needs to be incorporated with this? So here we see in Chapter 5, 503.5 talks about lighting systems. New lighting systems, go back to Chapter 4 for that. But what we see throughout lighting, new lighting systems, we need to comply. Go and see sections 405 and 408 for new lighting systems. Automatic receptacle control is adjacent to the lighting section in C405, but it is different. 405.11 is automatic receptacle controls. So what we encounter here is there's a little bit of a disconnect. Chapter 5 is always where we start for existing buildings, but there is nothing that points us back to automatic receptacle controls within the alteration section. The only thing that we point back to is new lighting systems. So for this purpose, because there is nothing that's pointing us back to where we would need to go if we need to add automatic receptacle control, we don't have to incorporate that for our existing buildings. So anything I might have missed on that, or is there any questions about how we in essence did not get from point A to point B on that? I realize it's a little bit of an odd phrasing to show here is something that does not exist.
Okay. All right. I think we can move on to the next question. So next one, question on doing an upgrade to some lighting. Do I have to upgrade the controls for that lighting? So for this particular question, if you're just doing a fixture replacement for a lighting upgrade, most likely you're not pulling a permit. And so per Illinois statutes in the Illinois admin code, you need to pull a permit in order to trigger compliance with the energy code for a project. If there isn't a permit, there isn't anything that triggers energy code compliance. So for a lot of minor lighting upgrade projects, without that permit, there isn't a requirement for energy code compliance. However, if you're doing a major lighting overhaul, you're replacing lighting in multiple spaces, it's a larger project, those might require a permit. So again, new lighting, we go start in Chapter 5. It refers back to Chapter 4, C405 and C408, C408 for lighting controls. And there are some exceptions that apply here. So let's walk through the process. So again, it's in existing buildings. We're starting in Chapter 5. We're altering a system in that building. So we're going to 503 for alterations. Again, we follow down through the section on alterations until we find the reference to what we're looking for, and that's the lighting systems upgrades. So new lighting systems that are part of the alteration need to comply with C405, which is the lighting power density and lighting control requirements, and C408, which is the commissioning requirements for those control systems. However, there is this exception here. If you've had to pull a permit for a project, you've triggered some energy code compliance, but if your alteration is replacing less than 10% of the luminaries in a space, note that's an individual space, not the entire building, provided that such alterations don't increase the installed lighting power, then you don't have to go back through and implement the lighting controls and commissioning and stuff that the energy code calls for. So when you're looking at your project area, what that's covering, if that's more than 10% of the luminaires in a space that are being replaced, then this exception would not apply. You would then have to go through and install those lighting controls and commission them as if a new lighting system.
Okay. So next we're gonna switch gears a little bit and look at sleeping rooms. So sleeping rooms, typically hotel, motel rooms, you know, do these require a master switch at the entrance door location? And so looking through and calling out sleeping units, there is a particular provisions for these. So 40525 has the requirements for sleeping units. And noting here that the master switch by the entrance is not required. However, the master switch is an option for compliance with the codes. So actually look at the code text itself. Again, we've already gone through chapter 5. It sent us back to section 405, power and lighting systems. So we are recognizing we need to comply with this, and code even calls out sleeping units need to comply with 40525 and either 40511 or 405.3. So this is kind of how we're going to walk through this and say, okay, we know we need to comply with 40525 and either one of these two. So we're going to start with what is the requirement that all of them have to. So sleeping units need to have the control device. So within 20 minutes of when occupants leave. So we have to have some methodology to turn the permanently installed luminaires off and the switch receptacles, presumably for table lamps, floor lamps, and other illumination that those would be plugged into within 20 minutes. So we need to have something for that. And from there, that we need them to have no less than 90% and be high efficacy lighting. Or the other one is going to be meeting the interior lighting power. So either we need to have our controls and either high efficacy lighting in at least 90% of the fixtures, or we've met the interior lighting power density with that. So we either need to have occupant sensing control in order to turn the lights off within 20 minutes of occupants leaving the space, or we can control them by key card controls. So this is where the code is calling out that you don't necessarily have to use MasterCard or master key card control for this purpose, but that's one of the methods that you can do in lieu of an occupant sensing control.
The next question we wanted to review is looking at exterior lighting requirements. So we've got an internally lit exterior exit sign, and the client wanted to know, does this fall into facade lighting? Is it decorative lighting? Is it somewhere else? Because those things have different requirements in the code. So looking at signage lighting, there are specific call outs for facade lighting controls, and then there's all other lighting. And so signage lighting would fall into that other category. You're not doing landscape lighting with it. You're not lighting up the side of the building for general aesthetic purposes. So you're not lighting up the facade. So it falls into that other category. So signage lighting does require controls per C405.2.7. It doesn't meet one of the exceptions for that section, but it doesn't have to be controlled itself. It can be included. There's a 50% setback requirement where you either do reduced lighting through motion sensing or timer controls. And that 50% setback can be dimming of all the lighting, or it can be switching off 50% of the fixtures in the lot. That could include the sign. It could exclude the sign. So let's go through the section and look at how we've come to that answer. So for this building, again, we're going to existing exterior lighting controls in C405.2.7. And we're looking at exterior lighting needs to comply with either 2.7.1 or 2.7.4. The exceptions here do not apply. So lighting is not controlled from within the dwelling unit. It's not part of the parking lot or entrance area that's used for eye adjustment to nighttime conditions. So neither of those exceptions apply, so we can disregard those. We are going to need to comply with one of these exterior sections for lighting control. So C405.2.7.1 is daylight shutoff. Lights should be automatically shut off in the daylight. So that's a requirement. All exterior lighting has to be off during the daytime hours through a control system. C405.2.7.2 is building facade and landscape lighting. Those have specific control requirements, but this is a sign. It's not building facade and landscape lighting. So what we're left with is lighting that is not controlled in accordance with C405.2.7.2. So we don't have to follow those specific requirements. So there's this general control requirement for all other outdoor lighting that is not facade and landscape lighting. So that's why I've highlighted the not there. And that lighting needs to be controlled such that 50% of that lighting power is reduced either through selective switching or dimming. And if you're controlling the exterior lighting through selective switching, the sign can remain on all night while another 50% of your outdoor lighting is turned off. Probably not likely to use dimming for that, but yeah, it could happen for some exterior lighting where you dim half the luminaires inside that sign fixture. It's still lit. You can still see it in the dark. It's just not as bright. That wraps up all our section questions on lighting and controls and things that we wanted to cover. So we'll start moving into mechanical and service water systems.
And for that sign, all we're recognizing is that needs to be part of your exterior lighting power calculation. So, and it says you need to reduce it by at least 50%. So you could include the sign as part of the 50% you leave on, or you can include it as part of the 50% you turn off. Either way, but it all kind of gets lumped together there as one thing. So with the mechanical, we're looking at a commercial kitchen for hot water. So have an existing space, has restroom, and we're going to be changing to incorporate a pretzel shop. So adding a 3-pan or 3-basin sink, wash, rinse, and sanitize, mop sink, and a hand washing sink. Do I need to add a water circulation system? And we're calling out here, and our answer is yes. You're going to generally, for commercial spaces, they mostly require circulation systems here because we have a alteration. So we're going from just a restroom into a commercial kitchen. You know, we definitely are likely to run into needing a circulation system. This is something that does come up is there is a substantial difference in provisions between residential and commercial. Commercial has a fairly limited a fairly low limitation as far as the length or volume of water between the fixture connection and a source of heated water. So, again, we're going to start in 503 to make sure we get sent back to chapter 4. So service hot water systems. So new service hot water systems that are part of the alteration. So because we are extending, then we have a new service hot water system and need to comply with 404 and 408. Again, 408 is service water heating, 408 is commissioning of those systems. So part of the reason we're calling this out is 404.51, maximum allowable pipe length. So public lavatory faucets have one set of standards, and all other fixtures and appliances have a different set of standards. And these can be fairly low. So looking from these new sinks, where is the nearest source of heated water? So that could be a circulation system, a domestic hot water heater, or even a point of use unit. So from the source of heated water to the termination of the fixture supply. So where the pipe comes out of the wall and that valve for the fixture. So that's where we're measuring to. So in order to achieve that, we will likely need to add a heated water circulation system in order to achieve that, in order to meet that maximum allowable pipe length. For public lavatories, I believe it's 2 ounces. So that's a very short pipe length. For all other fixtures, as I recall, it's half a gallon. So there's at least some length there. But for public lavatories, unless the water heater is under the sink or right on the other side of the wall, you're probably going to be needing to have a circulation system for that. Again, so this is part of the existing bathroom may not have required it, but all their new sinks would need to have that, since that's part of the alteration for that.
Our next question involves sizing of systems. So they have a condenser replacement permit. They've got a manual J back from the contractor showing the heat loss is 18,000, almost 19,000 BTUs, but they're specifying a 2.5 ton or 30,000 BTU unit. And they're wondering, is this correctly sized? Would they need to give you a reason if it's oversized for some purpose? So yes, some justification of unit sizing is required. As we go through the code, again, we're going to go to Chapter 5 for existing buildings. It's going to refer us back to Chapter 4 for mechanical system requirements. So new mechanical systems would have to comply with sizing requirements and things like that. Manual S prohibits cooling equipment larger than 115% of the calculated load. So it gives you that 15% buffer. Usually equipment's going to be one size up from the loads you've calculated through a manual J. And it also prohibits heating equipment larger than 140% of the calculated load. So again, a little bit of leeway there, acknowledging that systems provided aren't going to exactly match your loads all the times. Generally, picking the next size up unit complies with that manual S requirement. But as we're looking at this answer here, a 2.5 ton is more than just the next size up. So if the load doesn't show that system, those loads are there, that system would be oversized and not justified for installation. So again, we'll walk through our sections. It's an existing building that they're altering the mechanical system. So we're going to start in R503 for this residential property, looking at alteration of a system. And then we're scrolling through alterations to any building or structure shall comply with requirements for new construction. That is listed in R503.1. So any altered system that's part of this project needs to comply as if new construction. When we get down to R503.2.1, looking at heating and cooling systems for any more exact requirements, this refers only to HVAC ducts and newly installed as part of an alteration. They'll need to comply with the section R403. Note here that it's not talking about mechanical systems for this more exact reference back to Chapter 4. But in that main paragraph, R503.1, it does point back for compliance as per new construction for alterations to a building or structure. But this section doesn't refer back to the equipment sizing requirements. So there is a bit of this disconnect here with the specific reference to Chapter 4, because it's only referring to new HVAC ducts. However, again, we're looking at this first paragraph. where we've got this general compliance statement that alterations to any building or structure shall comply as per new construction with the code. And so that does trigger this efficiency, equipment sizing and efficiency rating requirements for new systems. And again, this is for existing buildings, ensuring that as we're upgrading systems, we're not just doing a one-for-one replacement of a system that wasn't working properly and is vastly oversized. It's going to be inefficient, even if we're putting new equipment on it. To ensure that that equipment is properly sized, that's both saving energy, extending the life, the operating life of the equipment, and saving on capital costs from not putting in equipment that's too large for the loads in the building. And so in this section, it's referring back to ACC Manual S based on a building loads calculation in accordance with Manual J. So that's where those references come in to those outside standards for equipment sizing. Or you could use another approved calculation methodology to size that equipment. There are software packages and stuff that are available. Most of them are based on the Manual J and Manual S sizing methodologies. And then here we just pulled a clip out from the Manual S. So you can see total heating capacity and cooling capacity, what those, where we source those requirements for. You got a little bit of leeway in sizing above your loads. So there's that 140% for heating capacity. There's the 115% for cooling capacity.
Right. Sunrooms. Want to add a fireplace to my sunroom. So the question came in, want to add a gas fireplace to the sunroom, but being told that that's not code compliant. How come? And so part of this is recognizing this may depend on if the sunroom is currently conditioned or not. And if we have an unconditioned sunroom, adding a fireplace now would move this from unconditioned space into conditioned space. And now we have a change in space conditioning. If it already was a conditioned sunroom, which isn't totally common, but has been known to occur. So if we already have a conditioned sunroom, adding a fireplace is not adding conditioning to this for this. So that's not a change in space conditioning. So that may not trigger some of these additional requirements for this. So, and how we're looking at this, starting in 202, recognizing what is a conditioned space. So first we have to evaluate, is this sunroom a conditioned space presently or not? So with conditioned space, so we're reading through, directly or indirectly heated or cooled. So this is where you might have a sunroom that is already indirectly heated or cooled. Indirectly meaning the ductwork is not necessarily going directly into the sunroom, but if it's already open to the living space, that is indirectly heated or cooled via the living space for that. So, and not saying a sliding glass door between the sunroom and the living space, but just a cased opening where it's just totally open to the living space. So, then we have, so if this is conditioned space, looking at this and saying, okay, what are the or if it's not, what are the insulation requirements? So the code does have a specific provision for sunrooms and heated garages. So sunrooms need to meet the insulation requirements of this code. So in order, if this is an unconditioned sunroom and we are wanting to add a fireplace to it, this fireplace is now a heating source. So this would now, if it had no heating source before and now has, or they are looking to add a heating source, now we are changing this from unconditioned to conditioned. So and noting sunrooms that are enclosing conditioned space, indirectly conditioned or indirectly heated is still conditioned, need to meet the insulation requirements. So as far as does it matter if this is wood fired or gas fired, it goes back to would a permit be required for this project? Not necessarily is one applied for, but is one required? That's perhaps a little bit of a nuance there, is recognizing that in the state of Illinois, if a permit is required, then compliance with the state energy code is required too. So first, making sure that we've insulated based on the requirements. And the second is looking at the fenestration. So sunrooms, enclosing conditioned space need to meet the fenestration requirements. Now we will call out that the insulation requirements for sunrooms is different than normal conditioned spaces. So for that, they do have some of their own specific requirements. And here we even see some of those in the exceptions. They call out, here are the fenestration and insulation requirements for sunrooms and heated garages for that. So recognizing that the code is specific. So again, throughout the code, existing buildings, we're always starting at chapter 5 and working our way back from there. And then throughout the code, the more specific requirements applies. In the event there is not a more specific requirement, then the general requirement applies for that.
So tying back to the original question of why might a fireplace not be allowed, the code doesn't allow space conditioning equipment outdoors. So if you're in an unconditioned space or an outside patio or something like that, you can't do an equipment sizing calculation for the system. Therefore, there's no way to properly size the system to comply with the code. So permanently installed heating fixtures outside the conditioned envelope for residential properties isn't allowed by the code. Where we get into a little bit of nuance again is if you're doing like a wood fireplace or a portable heater, those things aren't covered by the permit. So the code doesn't cover those kinds of things that are temporary in use. If you had like a fire pit on an outdoor patio or something like that. If you're doing a decorative fireplace that is not producing heat, then you're not changing the conditioning of that sunroom. So there's a couple of different nuances that play into this. If it's an unconditioned space, the code doesn't allow you to add in a permanently installed conditioning system. If it is a conditioned space, you could add that system in, but there are some other requirements if it's an unconditioned space already. So if you add the fireplace, now you also have to insulate the envelope. If that's not part of your project, then adding the fireplace isn't going to be allowed. So hopefully that answers a lot of the questions that came in with that one. So our next question is looking at ductwork insulation. An existing commercial structure had some roof top ductwork running horizontally along the roof to an access point in the building. So they're replacing those rooftop units. They're connecting into that existing ductwork. It has a duct liner in it already. Can that duct liner count towards the insulation value for that ductwork? And does that new ductwork have to have exterior insulation? So it's an existing building. We're going to start in chapter 5 again. It's going to refer us back to chapter 4 for mechanical systems. In C403.12.1, that's where it discusses duct and plenum insulation requirements. For exterior ductwork, since this is out on a rooftop, you need to have that R12 insulation. The interior liner, while it's generally not considered for its insulative properties, it does have them. They can be included in the R value calculation for that ductwork system. So let's kind of walk through the code text here. So again, we're starting in Chapter 5. This is a commercial building. We're altering a system on that building, so we're starting in the alteration section. We're going to move through that section until we get to C503.3, which is referring back to heating and cooling systems. So new heating, cooling, and duct systems that are part of the alteration need to comply with C403, which is the mechanical system efficiency requirements and controls requirements, and C408, which is the commissioning requirements. Since this is just a duct system, we don't have to worry about controls or anything. We're not commissioning anything. We're just tying into the ducts with the existing HVACs, with the new HVAC units. The new HVAC units are going to have their controls and stuff. All that will fall into that C408 section. But the specific question about the ducts, we're going to go through to C403.12, where we're looking at construction of the system elements, which includes the ducts, plenums, piping, and other HVAC components. In that section, we're going to scroll down until we get to the duct insulation requirements. That's C403.12.1. And this is where we find for ductwork that's in an unconditioned space, you've got that R6 to R8 requirement. And then when you're in outside the envelope entirely, in an outdoor space, for climate zone 4, you've got a requirement for R8 insulation. For climate zone 5, it's R12 insulation on any exterior ductwork. And again, the duct liner, while it's usually there for sound attenuation purposes, does have insulating value that can contribute to the R value of the insulation of that ductwork. And so we've highlighted those requirements there. As far as do any exceptions apply to this ductwork is outside the equipment, so that exception doesn't apply. The temperature difference is going to be greater than 15 degrees because it's conditioned air ductwork in the outdoor environment. At your design conditions, for certain, you're going to be greater than a 15-degree differential. So neither of those exceptions apply. You do have to insulate that exterior ductwork. But what about that interior liner again? So again, you can count it. There are some reasons you might not want to. Again, those liners are usually for acoustical purposes and not insulation purposes. So while they have some R value, it's usually not a significant amount. You're looking at maybe an R2 to R3. It may also be difficult to verify for the existing ducts what that liner R value is. And then those interior duct liners also often break down over time and introduce debris into the supply airflow. So now you've got an air quality issue. And also it degrades that R value over time for the existing ducts. So if you do have an interior liner, you may want to go ahead and play on the safe side and do the full insulation on the outside of the ductwork.
Okay. Looking at energy recovery came in. So in this case, it's a fairly sizable unit, 34,000 CFM with 7,700 CFM of outside air. So 23% outdoor air. So that's a piece we're going to need for our table. But saying, does this require energy recovery? So part of this is going to be looking at the airflow along with that percentage of makeup air. So starting at 403, we go ahead and get the table. I mentioned that we were at 23%, and this is going to be in climate zone 4A or 5A. So starting from that, so we follow the column down and the row across, and we say, if the design airflow rate is 16,000 or more, and we're operating less than 8,000 hours per year, then we need to have energy recovery. If this was operating 8,000 hours or more a year, basically continuous, then our limit's 130 CFM of total airflow design rate. And we mentioned earlier, this is 34,000. So regardless of how many hours it runs, energy recovery would be required for that. So.
Question came in about controls commissioning for a building. Does that have to be a third party? Is that mandated in the 2021 IECC? We'll go through the language and point this out, but no, a third party is not required for the commissioning. It can be the design agent It can be the registered design professional, or it could be an approved agency. So let's look at that language here. So for system commissioning, we're going to section C408, looking at maintenance information and system commissioning requirements. C408.2 is the mechanical system commissioning. And here at the very first section, it says the registered design professional or an approved agency shall provide evidence of mechanical system commissioning. So that can be the designer for the project, or they could contract out to an approved agency. As far as who does that approval is whatever's acceptable to the authority having jurisdiction. So usually it's going to be the code official. Same thing applies to functional testing for lighting controls. Again, it states here registered design professional or approved agency. So you have the option. It's not mandated that you have to use a third party to do that.
All right. So into some of the thermal envelope stuff. Had a question come in, what are the wall and ceiling insulation requirements? Have a couple of different tables depending on what you may like to use. U-factor provides a little bit more flexibility in how your assembly is put together. R value oftentimes has slightly higher performance, is accounting for some of the thermal bridges and errors in installation. But either of these methodologies is acceptable. This is oftentimes what we encourage people is if you're having difficulties, you're looking at the R value and you say, well, I'd like to build an assembly that's a little bit different than this is what the assembly needs to be, then that's where U-factor is beneficial for that. So an example of that might be the R value table calls for R13 plus 5 continuous, and you say, well, I'd like to use an R15 insulation instead of the R13. Can I trade off some of that continuous, or conversely, I'd like to use some R11 insulation and instead increase the continuous insulation. So having that U-factor is available for that.
Another question we had come in pretty frequently, we get roof questions. This one was an interesting one in that it was a bit unique. So they got a 3-flat residential building and they're replacing the roof. It is a wood framed flat roof with built up roofing on the exterior. There is some continuous insulation above the roof decking, and there's some in the cavities underneath that the owner of the building has tried to blow in some insulation over time. So they're wondering, as they're doing this alteration to the roof, what insulation do they need to install? So this is a cavity insulated assembly, which meets the exception number 2 under R503.1.1. We'll get to that section. So as you're doing these roof repairs, as you expose the cavity simply needs to be filled with insulation. And that's the only energy code requirement for this type of roof system. So we're going to start in the residential section. Since it's a residential property, it's an existing building. So we're in R5, chapter 5, and it's an alteration to the roof assembly. So we're in the alteration section. As we're going through that section, looking at the building envelope requirements, since this is part of the building envelope, R503.1.1 says that those alterations to the envelope need to comply with the insulation tables that Ryan was just referencing. However, there are this list of exceptions included in the section. And so as we're looking, this isn't a storm window thing, so that doesn't apply. However, it is a cavity assembly. So we've got existing ceiling, wall, or floor cavities exposed during construction are exempt from having to meet full insulation compliance with the code, provided that they're filled with insulation. So as long as those cavities are completely filled with insulation, those are compliant with the code.
More roofing stuff. So here we've got an old roof. Remove the insulation completely down to the deck. So it's a low slope roof with insulation above deck. And we've got some issues with the existing RTU curbs not being able to provide for the R30 insulation? Do we have to raise the equipment curbs? In short, the answer is no. This do need to tweak on the slide a bit, because the reason for no is there is now an Illinois amendment for this that has codified the past practice and past interpretation that the insulation needs to achieve the best that you can within your existing condition. And equipment curbs is one of the allowances for that. So for roofing insulation, looking through, it says it needs to comply unless one of these exceptions fits in, and none of those apply to this case. Roof replacement, they're calling out that roof replacements need to comply with the following requirements, where it's part of the thermal envelope and contains insulation entirely above roof deck. So as part of that roofing replacement, here are all the provisions that it calls out. Again, I will note that Illinois has recently passed an amendment that codifies and makes this one a little bit more clear for that. So again, this is saying in no case can you reduce the insulation value as part of this. For those of you who may have been involved with the code for some time, we also should call your attention to the tapered insulation provision that has also changed with the 2021 code substantially for this. So with this, noting we don't want to create an unsafe or overload existing building systems for that.
Our next question is, the client was having some difficulty interpreting the required R values for a 2- and 5-story residential building in Chicago. So they thought that the insulation requirements were based solely on the residential requirements here. And so this gets into the definition in the energy code of what is a residential building versus a commercial building, and not the uses of those buildings. So in the energy code, and as this was in Chicago, referring specifically to the Chicago Energy Transformation Code, a 2-story building with primarily permanent occupancy falls under the residential provisions. It would get those residential insulation requirements. A 5-story building, however, falls under the commercial provisions, and there's a column in the commercial table for insulation requirements for residential properties, Group R properties. And so the insulation requirements pulling from the Chicago Energy Transformation Code for the 2-story building are going to come from the residential tables, but for the 5-story building, even though it's residential occupancy, is going to come from the commercial side of the requirements. And so as we go through the Energy Transformation Code, we go into the definitions to figure out what is a residential building versus what is a commercial building. So a commercial building is anything that is not meeting the definition of a residential building. So then we need to keep going through to find that residential building requirement. And for a residential building in this code, it's a group R2, R3, R4, or R5 occupancy with no more than 4 stories above grade plane. That's specific to Chicago Energy Transformation Code. In the rest of the state, it's 3 stories above grade plane. So that's why there's a slightly different requirement for these 2 different buildings. One falls in the commercial because it's exceeding that 4-story limitation. The other does qualify as residential. As far as the insulation requirements, we've pulled out the commercial requirements here. This is a Group R building, so we're looking at the Group R column for the insulation requirements. For the roof deck, it is that R30 continuous insulation. And then for the walls, depending on how they're framed, here we've picked the wood framed for this project. You have a couple of different options for how to meet that framing requirement listed in that R value table. On the residential side, we're looking at wood frame roof or ceiling. The R value for those is R60. And then for framed walls, there's multiple selections there.
And I did see a question or two come in regarding decorative fireplaces when we were talking about sunrooms and fireplaces. Part of that may depend on again, part of this is the fireplace capable of providing conditioning to the space? So a purely decorative fireplace. So in the in an example, my house, I have a fireplace with no chimney. That would be a purely decorative fireplace that it has a little display of a fire on it. So that would be a purely decorative and would not make a space conditioned. But if someone puts in a fireplace and it has a chimney and it has the capability to provide heat to a space, that is a conditioning appliance.
I had a question here too, as we were talking about the roof assemblies, and we've talked about sunrooms and porches. Someone brought up that porch replacement projects are a major part of construction work in the city of Chicago. So if the porch is enclosed, does only the porch enclosure have to meet the envelope requirements of the R20 and R5 in the walls? And again, this comes back to, is that enclosing conditioned space or not? So if you're enclosing a porch and it's still thermally isolated from the house, you don't have a permanent opening with an unweather stripped, uninsulated door, where you have free communication of air between the conditioned space and that porch that would then indirectly condition the porch, or you don't have a direct conditioning like a duct extension or a supplemental heating and cooling unit on that porch, then it does not need to meet those thermal envelope requirements in the code. If it is conditioned and it's a sunroom addition to the porch, you've got a large amount of glazing, there are some special requirements for sunrooms, as long as they remain thermally isolated from the rest of the house. But the sunroom itself is conditioned. There are slightly less stringent insulation requirements. If it is communicating freely with the house, it's not thermally insulated, then it would have to meet those envelope requirements, the R20 and the R5. Yeah.
And recognizing that the sunroom may also contain in a porch application, you may have, depending on your design, not only walls but the ceiling and floor to contend with too. So just by enclosing a porch and making it a sunroom, if you don't add any conditioning, there's no specific requirements as far as those walls or anything. They don't have to meet insulation requirements if it's still remaining an unconditioned area from your unit.
We did have one question on clarification of controlled receptacles. In the 2021 IECC, it's kind of aligned now with ASHRAE 90.1 that has had controlled receptacles in it for a while. But 50% of the receptacles in a commercial space need to be controlled by an automated system. It could be time clocks, could be occupant sensing controls, could be load sensing controls, but something that turns off 50% of those receptacles, switching off unnecessary equipment that's plugged into them to minimize plug loads in buildings. So that's what the controlled receptacles is referring to. I believe that's all the questions that have come in. So again, we've run a little bit long answering the questions. We didn't get to cover all the Q&As in our presentation. Hopefully when we do future updates, if you want to come to our in-person workshop, we'll be covering those Q&As and how we answer them again. So if there's something we didn't address and you would like to see done, let us know. We can include that in our in-person workshop.